A special type of mean is called a weighted mean. And a weighted mean is just a method of computing a mean of a set of numbers in which some of the elements of the set carry more importance or more weight than others. So when you're calculating, for example, grades, grades are often computed using a weighted average or a weighted mean. Because often there are different elements in the set, such as homework, quizzes, tests, or a final exam, that carry different varying degrees of importance or weight. So this is a common weighted mean calculation. Now, if your course you're taking just has 4 tests and they all count the same, then you would just take the regular mean of that data set, add up the 4 total scores that you earned, and divide by 4. But frequently, grades are composed of weights because there are different elements in the set that some are more important than others. So here's an example. We'll see how we would compute this through this example. So in this case, we've got homework and quizzes and a final exam in a course. And the homework counts 10%, the quizzes count 20%, and the final exam counts 70% of the total grade. So Pat has earned his scores, and he has a homework grade of 92, a quiz grade of 68, and he made an 81 on the final exam. So what is his average grade in the course? In other words, what's the weighted mean of this data set? So one way to organize this information and do this calculation is to use a table. So in our table, we will have homework, we will have quizzes, and we have the final exam. And each one of these carries a weight. I'll use a lowercase w to represent that. Now, when we calculate with percents, we have a choice here. We can use the percent as it is, or we can change it to a decimal. I'm going to change these to decimals, so the 10% would be 0.10, moving the decimal 2 decimal places. The quizzes were 20%, or 0.20, and the final exam was 70%, or 0.70. And we want to check here and make sure that the weights all add up to 1. Now, if we kept the percents in here, 10, 20, and 70, obviously they would add up to 100%. But that's what 1 represents here as the decimal. So we've accounted for all the possible elements in the set. So what were Pat's scores? Well, on the homework, he had a 92. On the quizzes, he had a 68, and his final exam grade was 81. So to compute the weighted average, we want to apply the weights to each one of these scores through multiplication. The weight times the score, and get these values. So 0.10 times 92 is 9.2. 0.20 times 68 is 13.6. And 0.70 times 81 is 56.7. So now we add this up and get the total, 79.5. So what we found is to find the weighted mean, we want to find the sum of the weights times, in this case, test scores, or whatever the element was in the set, whatever these numbers were, times their weight, divided by the sum of the weights. Now, in our case, the sum of the weights was 1, so we're essentially just dividing by 1, or in other words, our total would have been fine, just to use the total. But remember, I said we could have left these at 10, 20, and 70. these numbers of course would have been larger by that factor, and we would have had to divide then by 100, and we would have gotten the 79.5. So it's just a preference there when you're working with percentages. So now we see that Pat's weighted mean in the course is 79.5. Another common weighted mean calculation is a GPA calculation. So let's look at an example. Last semester, Pat earned the following grades: A in fitness, B in speech, B in prob and stats, C in biology, and a B in Comp 1. The credit hours for these courses were: in fitness, 2-hour course, speech is a 3-hour course, prob and stats is a 3-hour course, biology was a 4-hour course, and Comp 1 is a 3-hour course. So if the grading system assigns quality points as shown below, compute Pat's grade point average, or GPA, for last semester, rounded to 2 decimal places. So the quality points associated with each letter grade are shown here. An A earns 4 quality points, a B earns 3, a C earns 2, a D earns 1, and an F does not earn any quality points. So let's make the table like we did before and calculate Pat's GPA. So for each category, let me write those down. We have fitness, and we have speech, let's see, slide this up a little bit. We had prob and stats, just abbreviate that, and we have biology, and Comp 1. Okay, so Pat's grades, let's check that again. So in fitness, A, speech was B, prob and stats B, biology C, and Comp 1 was a B. Fitness A, speech B, prob and stats B, biology C, and Comp 1 was a B. Okay, now what's the value of each one of these letter grades? Well, that's what the quality points tell us. The value of the letter grade A, B, C, D, E, D, and F. So for an A, he would have earned 4 quality points. For a B, 3 quality points. A B is worth 3 quality points, a C is worth 2, and this B is worth 3. So we use these letter grades just to represent the actual value of the letter grade. But now, the reason this is a weighted mean is that fitness A, that's great, he made an A in fitness, but how much weight does that get? Well, the weight is represented by the hours of that course. So fitness is a 2-hour course. Speech, a 3-hour course. Prob and stats, 3 hours. Biology is a 4-hour course, and Comp 1 a 3-hour course. So we could sum this column to get the total number of hours Pat took last semester. 2 plus 3 is 5, plus 3 is 8, plus 4 is 12, plus 3 is 15. So he took 15 hours, but they were different weighted courses. 2-hour courses, 2 3-hour courses, and a 4-hour course. Okay, so just as we did before, we want to calculate these values that are assigned to the letter grades times the weights. Remember last time when we were calculating an average in a course for Pat's values here were his averages for his final exam, for his quizzes, and for his homework. Okay, so now we multiply across. 4 times 2 is 8, 3 times 3 is 9, 3 times 3 is 9, 2 times 4 is 8, and 3 times 3 is 9. Okay, and we want to get this sum: 17, 26, 34, 43. And so recall that that mean that we're looking for, we found before by taking the sum of each value times its weight and dividing that by the sum of all the weights. And recall last time in the other problem, this turned out to be 1 because we had changed our percentages to decimals. But here we see that that denominator is going to be 15 and our numerator is going to be 43. So when we divide this, we get an irrational number. I'm sorry, it's not an irrational number. That continues on and on and on with the 6 repeating, and we're to round that to 2 decimal places. Let me correct myself again. It's not an irrational number. It's a rational number, but it continues with repeating 6s. We're supposed to round to 2 decimal places. So his GPA 2.87. A GPA is an example of a weighted mean.